All right, guys, 1,1D is on clearing fractions. So looking at the top of 1,1D, it says x plus 3 over 2 equals 5. In order to solve equations up to this point in 1,1A, 1,1B, 1,1C, we've been working on combining like terms and solving two-step equations. We talked about undoing PEMDAS in order to find the value of a variable. So in order to do this, technically this fraction bar means divide, right? If I have 3/4 of a pizza, I have less than a whole pizza, and we're dividing. So the opposite of dividing here is multiplying. When I multiply this by 2, when I multiply this left side by 2, I also need to multiply the right side by 2. So I'm going to be left with, when I multiply by 2 or 2 over 1, those 2's eliminate, and I'm left with x plus 3 equals 10, because 5 times 2 is 10. I'm going to subtract 3 on both sides. We get x equals 7. All right. The second one, very different. The 3 is not on top of the fraction bar, so I need to get rid of that 3 first. The opposite of adding 3 is subtracting 3. So I'm left with x over 2 equals 2. Now I'm going to multiply both sides by 2 again, for 2 over 1. Multiplied by 2, we get x equals 4. This next one, very different. When I distribute that 1/2, I'm left with 1/2 x plus a half of 3 is 1.5 equals 5. I'm going to subtract 1.5 both sides. I'm left with 1/2 x is equal to 3.5. I'm going to multiply both sides by the reciprocal of 2 over 1 or by 2, and we get x equals 7. This last one, how would I figure this out? Well, I'm going to multiply both sides by 2 again. When I do that, multiply that top half by 2, I'm left with x plus 3 is equal to 5. I'm going to subtract 3 on both sides. X equals 2. Okay. It says down here, solve each of the equations in the space below. Did you find that some equations were easier to solve than others? Why or why not? Yes. And the reason why is because fractions are tough. There has to be an easier way to solve these. And so to do that, when faced with an equation with fractions, we can move things around in an equation that does not contain fractions. This is called clearing the fractions. Okay, it makes it easier. In the problems above, in order to clear the fractions, we had to get rid of that 2 in the denominator of each. So let's go down here real quick. To clear the fraction, I'm going to look and see, okay, what's on my denominator? Here is a 4. In order to get rid of that 4 to clear the fraction, I'm going to multiply everything. First step is put everything in there in parentheses. I'm going to multiply everything in parentheses by 4. Watch what happens here. This 4 is going to be multiplied by to the x minus 1 over 4 and to the 6. So the easiest part of this for me is to bring down that equal sign. What is 4 times 6? 24. Now when I multiply 4, or 4 over 1 times x minus 1 over 4, that's the same as saying, okay, well, what is 2 over 1 times 1 over 2? 2 times 1 is 2, 1 times 2 is 2. I get 2 over 2 or 1. Some of you were taught to cross simplify. All right, the same thing is going to happen here. These 4's, when you multiply this 4 over 1 times x minus 1 over 4, those 4's are going to eliminate. So I'm just going to be left with x minus 1 equals 24. Now I'm going to add 1 to both sides. And I get x is equal to 25. Clearing fractions. Let's go ahead and try. We're going to try number 3. Looking at this, first thing we need to do is put parentheses around everything. Now there's a couple different denominators in here. What are my denominators in this problem? Well, I've got a 2, a 4, and a 4. What you want to do for these is you're going to want to multiply, and we're going to explain why in class, but you're going to want to use the bigger denominator here. So we're going to multiply this whole problem by 4, and I like to draw in my arrows so I remember to multiply everything in there by 4. So here, when I multiply 4 times x over 2, I'm going to end up 4 times x is 4x over 2 plus, when I multiply 4 times 1/4, I'm going to get 4 over 4, which is the same as just 1, is equal to, when I multiply this 7/4 times 4, the diagonals cancel. I'm left with 7. Can any of this be simplified further? Yes. Now you might also see back here when I do 4 times x over 2, if I were to give you this problem, 4 over 1 times 1 over 2, could anything be simplified in there? Many of you are probably saying, yeah, I can cross off that 2 and make that a 1, and this 4 could become a 2. Yeah, same thing here. All right, this is going to simplify down. So when I simplify that, we get 2x plus 1, 7. I'm going to subtract 1 on both sides. I get 2x equals 6, so x equals 3. Guys, this stuff is tough. So if you're having a hard time with this, that's okay. Let's keep working on it, and we'll keep working on it in class, okay? So let's try another one. Let's try number 4. Distribute. When I do that, actually, we're going to skip 4. We're going to come down to 5. Number 5. Problem here, guys, is that this 4 doesn't have a 3 in the denominator. So when we do this, we need to ask ourselves, okay, well, how can we clear these other fractions? We can multiply all of this by 3. Watch what happens. This 3 and that 3 cancel, so I'm left with 2x, or they clear, plus, what is 3 times 4? 12. Equals, when I do 3 times 14/3, those 3's cancel, I'm left with 14. I'm going to subtract 12 on both sides, and I'm left with 2x equals 2. So x has to equal 1. All right, number 6. What's my denominator? 5. Great. In parentheses, we're going to multiply everything by 5. 5 comes here, 5 comes here, 5 comes here. When I multiply 5 times 4/5, that's the same as 5 over 1. These diagonals eliminate. I'm left with 4 is equal to. What is 5 times 3x? 15x. What is 5 times 1/5? Well, those diagonals, the numerator here and the denominator here, are going to eliminate. So I'm just left with plus 1. I'm going to subtract 1 on both sides. Get 3 is equal to 15x. This is going to be a fraction. So we end up getting x is equal to 3 over 15. Let's go ahead and try number 7. My denominator is 3, so I'm going to multiply everything times 3, up top and in the bottom. 3 times negative 2. Oh, you know what? No, because this is 3 over 1. So my diagonals cancel here, and I'm just left with negative 2x minus 5 is equal to, what is 3 times 3? Well, 9. Do I know how to solve this? Yeah, we're going to add 5 to both sides. I'm left with 14 is equal to negative 2x. Divide both sides by negative 2. X is negative 7. I'm going to have you guys go ahead and try number 9 on your own. And I'm going to show you guys number 10. A couple different ways to solve number 10. Okay, if you look at this, 1/2 of 4x will give you 2x. 1/2 of 12 will give you plus 6, or 6 equals 2. That already cleared for you. Why? Because you're taking a half of even numbers. Now, if those numbers were odd, it wouldn't be as pretty, but we'll take it. So I'm going to subtract 6. We get 2x equals negative 4. Divide both sides by 2. We get x equals negative 2. Final answer. All right, number 8 is very similar to number 3 in the sense that we have different denominators. What is the least common denominator between 12, 3, and 4? Well, 12, and we'll talk about least common denominators in class tomorrow. So that means I want you guys to try and multiply everything in here by 12. I'm going to have you guys try this one on your own, and I'm going to have you try number 9. I believe you already did that on your own. So 8 and 9 tonight for homework. We're going to keep working on this, guys. This stuff is tough. So do your best. Come with questions tomorrow. If you don't get it, okay, shoot me an email. Let's talk through it. But I do want you guys to have this stuff done tomorrow. We're going to go over additional problems and answer any questions you have in class. All right? Great job today. That is 1-1D.